Hi there guys, please don't get too excited when you see this first question. This is not what we're doing today. We're going to be simplifying algebraic fractions. But basically, if you understand how to simplify this one, you will understand how to simplify algebraic fractions. But too many people don't make the link between the easy ones and the more complex ones. So how would you do this? I'm pretty sure you would be thinking of dividing top and bottom by 3. Now, the reason we can do that is 12 could be written as 4 times 3 and 15 could be written as 5 times 3. So when we simplify fractions, we can divide by whatever we want to, but we have to do it to the entire top and the entire bottom. So if I was to divide top and bottom by 3, I'm technically cancelling them out, getting 1s, and I get an answer of 4 over 5. And you've been happy with that for many years now. But as soon as we up it to something like this, people panic. But notice what's happening here, multiplication. And you can see that this factorised form, the beauty of factorising is when we do it, we turn addition and subtraction into multiplication. So is there anything I can divide the entire top here by and the entire bottom by? And yes, I can divide top and bottom by an x. They will go. So that will leave me with an answer of x plus 2 over x plus 3. That's a pretty simple one. Moving over here to the one on the right, now I can see I've got x plus 4 times by x minus 1, and on the denominator I've got x minus 1 times by x plus 1. So, this isn't the same question, but let's say that's a 5, okay? Let's just say that one's a 2. It's not, but I'm just making this up. I have to put a 2 there because they're the same bracket, and let's just put another number here. So if it was like this, I'm pretty sure you'd happily go, right, I can divide by 2 top and bottom. And I'd be left with the one on the left, which is x plus 4, and the denominator would be the one on the right. It's not harder than that, but people like to think it is. Okay, so let's up it a little bit more. So now you can see that we've got addition. Now, I'm going to show you what most people do here, and I'm going to explain to you why it's awful and hideous. They go like this: oh look, there's an x squared. Just get rid of them. And they just write a really rubbish answer, or sometimes they go a bit further and go, let's get rid of those x's as well. Please don't do that. It's not 3 over 19. Now, the reason you can't do that, because if I was to divide the top by x squared, I would get 1 plus 3x over x squared, because I have to divide the entire top by x squared. So you can see already why that's a really stupid thing. So we're not going to think about dividing top and bottom until it's written with multiplication, like the very start. And to do that, we have to factorise. So if I factorise the top first, because that looks way easier, because there's a single bracket, because there's a common factor. The great thing about these, compared to factorising alone, is I'm now expecting one of these brackets to be this. So x and x for x squared, factors of 12 that make 7, well that is 4 and 3. So it's a pretty simple factorising problem, but often when it gets tricky, I'm going to use top and like an easier one to help me solve the bottom one. So if I cancel those, remember they are 1s because I'm dividing top and bottom by the same thing. So anything divided by itself is 1. But you don't have to worry about that too much. Okay, so that's a simplified version. Don't cross out the x's. Okay, if you attempted to divide by x, you would have this. That is not a simplified version. Ugh. Okay, let dots. I'm sure you saw that as well. X plus 3, x minus 3. Denominator, factors of 3 that make 2. Well, that's 3 and 1. It's a prime number. And we have to do that to make the positive 2. So we can cancel these off. And we get x minus 3 over x minus 1. Remember, I'm cancelling these off because I'm dividing the entire top by x plus 3. And I'm dividing the entire bottom by x plus 3. So there you go. Okay, sorry how this is written, but it's from another website. I just hate these x's and these 2's look ridiculous. But I'm going to just factorise the top. So x plus 8. So I'm expecting either this or this to feature on the bottom. There isn't a highest common factor, so it's 2, so I know one of these brackets is going to be x plus 8, so I'm going to pop it in, and I can see the other one must be a 2, because 2 times 8 is 16, and 2 add 8 is 10. Divide top and bottom by that, and we have our answer. Now if your factorising is slow, yeah, you're going to be a bit slower on these, but it's going to speed you up. Now we're in some harder territory. So if I ask you to factorise that numerator, that's pretty tough. So some people do it through trial and error, that's what I'm going to do. Some people like to use the AC method or the quadratic algorithm, whatever you call it. But I'm going to show you a neat way of doing this. Now to start off with, I'm going to look, is it easier for me to factorise top or bottom? Well, definitely the bottom, it's a highest common factor problem. So x features in both, and that would give me 3x plus 1. Now I can see the top is going to be a double bracket because there's no highest common factor. And I know one of these brackets is 3x plus 1. And I know that because they're asking me to simplify it, and they wouldn't ask me to do that if I couldn't. So that really helps me because now I can just play around with the numbers to make it equal this numerator. So 3x times what is 3x squared? Well, that has to be an x. And I've got a 1, and I've got to times it by something to make a 2. So that has to be that. It has to be minus 2 really. 1 times negative 2 is minus 2. Let's just check it. Minus 6x plus 1x, using my outers and inners. There we go. So I haven't actually factorised that numerator in a normal fashion. I've used the easier one. So you can see I can divide by 3x plus 1 to top and bottom, and there is my final answer. Can't cancel the x's. Okay, so this looks a bit of a harder one, but it's dots again, isn't it? So it's 2x plus 5, 2x minus 5. Always look for dots. Now, that denominator, that ordinarily, try and error would be quite tough, because the 6 would have like possible options here, so like 6x and x, 3 and 2. The 5's quite nice because it's prime, but there is a total of 4 combinations. But look at the top. We know one of them has to be 2x and a 5. We're not sure of the sign. But what that tells me, if I'm using a 2x, this must be a 3x, because 3 times 2 is 6. So it helps me whittle down all the combinations. That's a prime, but it doesn't really matter anymore because I know I've got to have a 5, so it'd be 5 times whatever makes this number, but in this case it's 5 times 1. So now I'm going to look at my outers and inners. So for my outers I get 15, and my inners I get 2, and I have to make 13, so I have to do 15 take away 2. So that's much quicker than factorising, isn't it? So 2x minus 5 over 3x minus 1 when I divide top and bottom by 2x plus 5. Okay, I think this is my last one. No, I've got another one. So lots of treats. Now that looks pretty hard. The top one is hard. The bottom one looks like dots, but it's they're not square terms. But it is. It's dots in disguise, and I know that because if I look at the denominator, I'm actually going to do it down here. I've got a highest common factor of 3. When I do that, it unveils dots in disguise. So I'm going to do that first. 2x plus 3, 2x minus 3. Okay. So the numerator, there's no highest common factor, and I know one of them has to be a 2x, and one of them, so one of them has to be 2x and a 3. We're not sure whether it's a plus or a minus yet. To make the 6, this is very similar to the one before, has to be a 3x. And you can see here, this is not prime, so this normally would have a 1 and a 15 or a 3 and 5 combination. But because I know one of them has to be a 3, that has to be a 5. Okay, play around with the outers and inners, so we're going to have 9 and 10. We need to make 1, so we have to have minus 9 plus 10. So we're going to cancel out these two, and we have 3x plus 5 over 3 lots of 2x plus 3. If you wanted to, you could put 6x plus 9 there, but I wouldn't bother. Last one. Yeah, it's definitely the last one. Okay, right. Now, there's no dots in disguise, there's no highest common factor. This is tough. Which is going to be easier for me, top or bottom? Definitely the bottom, because I've got prime and prime. So I'm going to show you how I do these very quickly. Only option is 3x and x. Now, I've only got to really consider two possible options now. It can either be a 1 and a 3, or it can be a 3 and a 1. They're the only two combinations it can be. But you can see with this 3 being here, it is going to have an effect. Let's just look at the first one. So my outers would give me 9 x's, my inners would give me 1x. So you can already see I've got what I needed to, so I'm just going to get rid of those. If that didn't work, I would just do it again the other way around. But it did, so happy days. So I need minus 9x plus 1x. Well, that's great because now I know... Oh, well, actually I don't. This isn't really helping me because I could go 3x, and so I've actually just got to do this one now. So normally it's the middle factor pairs, so I'm going to go for this one. And I'm going to put a 1 and a 5 there because it could be a 5 and a 1 or a 1 and a 5. And let's just fingers crossed this works. So, in fact, actually, I wouldn't try the other way because I have 3x, so I'm seeing if the 3x plus 1 is going to cancel. If I put 3x plus 5 and 2x plus 1, I wouldn't be able to cancel anything, so that would have been really stupid of me. So 15 and 2, it worked. So 15 and 2 made the 17. I can cancel those, and I would get 2x plus 5 over x minus 3. That one is pretty tough, and I got a bit lucky if I'm honest. But if you try the middle factor pairs, you often do get lucky. The extremes, they're normally pretty obvious to spot as well, but the middle factor pairs are normally the answer. So I'm sorry if that last one is a bit confusing, but in the worst case scenario, you're just going to factorize top and bottom and look to cancel. But always have in the back of your mind, you're expecting exactly the same bracket, top and bottom, so you can cancel. Good luck.